All right. So here's what we're doing for, I believe this should be 2.5 now. Yeah, I think it is. All right. So 2.5 is over factoring expressions, which, I mean, this is kind of difficult. I'll just call it what it is. Factoring expressions can be a little difficult at first. You're going to get to where hopefully you get really good at this because you're going to do this in Algebra 1, Algebra 2, maybe in geometry a little bit. But anyway, we're going to look at basically separating an expression back into a product. So here's kind of what we're doing. If we were to start with this, like let's just focus on this first. If we were to look at this, we would distribute this 2 to x and 4, right? If I just said, hey, simplify this, you would say, okay, 2 times x is 2x over here. 2 times 4 is 8. What we're doing is actually the opposite. We're going in the reverse direction. We're actually saying, hey, we have this. Let's put it back into a form it's like the opposite of distributing, but we call that factoring. So now we're going to say, okay, we start with the simplest form. Let's change it back to a factored form. All right. So you'll notice what we did to do that. First of all, what we did here was multiply by 2. So here we do the opposite. We divide by 2. Now, that's going to not always be the case. Like it may be 2 sometimes, but not all the times. There's actually a process we have to go through to get that. But just understanding what we're doing is a big part of this. So make sure we understand when we factor, we're actually trying to reverse distribute. So we should end up with a number outside times, or it could also be a variable, but a number and a variable outside, something outside of a parentheses, and we could multiply that back into the parentheses. And if we've done this correctly, here's how it actually works. If we start with this, and then we factor it, or actually, let's go back. If we start with this, and we factor it to get this, we should be able to then distribute that and turn right back around and get this simplified version. So it kind of works like a circle. We should be able to go round and round and make it to where we could just keep going back and forth between these two. That's how you know you've done it correctly. All right, so now let's go through the steps. So the steps for this are pretty straightforward, but I mean, one of them is kind of difficult. So let's read through them first. So first, we're going to find a GCF, or greatest common factor. That means factor, which, let's just look at this. Factor means you can divide it by a number, or multiplies to give you a number. So when we talk about factor, we're saying can divide a number, okay? When we say it can divide, we mean divide it evenly or get a whole number out as a result, all right? So when we say greatest common factor, we're looking for the biggest number that will divide each term. So we want to know the biggest number that divides each term, and it has to be the same number. So what number do they have in common that will divide both of them? And we want to find the biggest. Now, once we find the biggest, we're going to divide each term by that GCF and leave the remaining factors in parentheses. So I'll show you how to write that. And then notice what step 3 says, check our work by distributing. That means, like I told you up here, if we factor this into this factored form, we should be able to then distribute it back and get the version we started with. So it's like one big circle. So let's go through this slow, and then we'll try to speed it up. So first of all, it says factor each expression if the expression cannot be factored right prime. So here's what that means. Well, actually, let's do this. Let's do prime separately. We'll handle prime in a minute. Right now, let's just focus on factoring. So look at number 1, 7x plus 7. Now, here's what this basically says. It says we have a variable term plus a constant. We want to reverse distribute this or factor it, and we want to end up with a version that looks like this. Now, to do that, we have to find the GCF of 7. Now, easy for you or lucky for you, 7 will divide itself, right? So if the number divides itself, or if the number is the same, that means that number is the GCF. Because 7 will divide 7, and this 7 will divide 7 as well. So here's what we do. We take that 7 out of the of the um, of the expression. So we're going to take out these 7s. Now, here's what that means. We're actually dividing by 7. So then what we leave in parentheses is the result of that division. So 7 divided by 7 is 1, so we're left with x on the inside. And then 7 divided by 7 here is just plus 1 on the inside. So now, this is our factored form. All right? Now, watch what happens if I start with that factored form and I try to go back and distribute again. This should always happen. 7 times x plus 1. Let's distribute this. 7 times x is 7x. 7 times 1 is 7. We could keep going in this circle all day, but we should do this every single time to make sure we get the answer right. If you distribute it back and you don't get the same thing you started with, that means you're just not doing it correctly. So, I mean, it sucks when you see that happen, but at least you have a way to see if you got it right or wrong. All right, so let's do another one. And at first, these are pretty simple, but they get a little bit more complicated. So yeah, let's start with the easy ones first. So number 2. Number 2, we have 4k plus 20. So we want to factor this. So we want to look at 4 and we want to look at 20. Right now, we can kind of ignore the k. When we get to some harder versions of this, you will have to pay attention to that k. But for now, we can ignore it. Essentially, you can also factor out a variable, but I think for pre-algebra, I don't think we'll ever have to really do that. Let me double check to make sure I'm not crazy, though. Yeah, right now you won't have to worry about that. But let's do this. So let's just start with the coefficients and do those first. So 4k plus 20, we have 4 and we have 20. Now, if we look for factors for 4 and 20, let's say, okay, what numbers will divide 4? So we know that 4 can be divided by 1, 2, and 4. We know 20 can be divided by, which you don't have to do this every time. I'm just going to do it for those of us that need to do this every time. So 20 can divide by 1. You can divide 20 by 2. You can also divide 20 by 4, 5, and let's see, 10. And then, of course, 20 by itself. So the greatest common factor is saying, what do these numbers both have in common? What's the biggest number they have in common? And it would be 4. All right. So what we're going to do is divide 4 by each of these terms. What that means for us in our factored form is that we're going to write 4 outside of a parentheses. And then what's in the parentheses is the result of that division. So 4 divided by 4, well, 4k divided by 4 is just k, plus 20 divided by 4 is 5. So this is our answer. Now, once again, we can distribute this back, and as long as we've done this correctly, we should get the same answer. So let's see if we get the same answer or we get the original. 4 times k is 4k. 4 times 5 is plus 20. That's exactly what we had at the beginning, and that should always happen. Like, I'll show you an example of what it would happen. Like, we'll do the next problem, and I'll show you what would happen if we picked the wrong number. So let's go to number 3. All right, so number 3. Let's just say, I don't know. Actually, it's kind of hard to pick the wrong number. Let's do 3, and I'll show you how we could write it the wrong way. So let's say we look at 5, we look at 15. Now, for this minus sign, you just have to remember that that's a minus sign. So that means you're probably going to bring that minus sign down, but you just have to pay attention to the signs when you divide. That's all that minus sign really means, is when we divide, we have to pay attention to it. But let's do this. We have 5, we have 15. Now this variable, or this variable term has m. This one does not. So we already know that pretty much means you can't take out an m. Okay, so let's just leave m there. Let's look at 5 and 15. 15 and 5 have the GCF of 5, because 5 will divide itself and it will also divide 15. But let's say when we did this division, we got the wrong number. So let's say we brought the 5 out here, out of the parentheses. We divided here correctly and said m, and then let's say we said, let's say we said plus 3. All right, let's act like we did 15 over 5 correctly and we said plus 3. Now, watch what happens if I check my answer. It's going to be a small difference, but there will be a difference. 5 times m plus 3, if I distribute, I get 5m plus 15. Now, is that what we originally started with? You should tell me no, because this has a plus, this has a minus. So that's one mistake that can happen. Now, hopefully it's pretty clear what we did. We just didn't account for this negative. So this is actually like saying negative 15 divided by 5, which would be a negative number. So this would be minus 3. All right. So then when we multiply it back and distribute it, we would end up with 5m minus 15, which is what we started with. But let me show you another example. Like, let's say we just got confused and said 15 divided by 5 is 2. So let's say we had this. Let's say we had 5m minus 2. Watch what happens when I distribute that back. I get 5m minus 10, and that's not what we started with. So that's why distributing back can be so useful to check when you get the wrong answer, or check and make sure you got the right answer. So let's look at another example. Let's just do one more quick one. Let's do number 5. So try to do this by yourself. So pause this, try to do it by yourself. So 12w plus 24. We want to factor this. All right, so the GCF of 12 and 24 would be actually 12. We can divide 12 by itself, and we can divide 24 by 12. So we're going to divide it by both of these and take it out of that expression. So it's going to be outside of a parentheses by itself. Then these two would cancel. W's by itself. 24 divided by 12 is going to be 2. All right. So now we could distribute this back and we would end up with, let's see, 12w plus 24. So that means we did that part right. So that's how quick it can be once you get pretty good at these. All right. So now let's look at a difficult, maybe not difficult, but here's an example of prime. So we talked about prime at the beginning, right? We talked about if it cannot be factored, write prime. Here's when it cannot be factored. So if you can't find a GCF, so can't find GCF, that means prime. All right, so if you look at 2 and 9, let's list the factors of 2 and 9. So 2 can be divided by 1 and 2, nothing else. 9 can be divided by 1, 3, and 9. The only one they have in common is 1. Now, here's why this is prime, because if I look at 1, let's divide both of these by 1. That would just be 2p minus 9 with a 1 on the outside multiplied. And we just don't have to write that. That's not really how this would write. We're not really changing 2p minus 9 at all. We would just keep going in circles. So when that happens, your answer is prime. All right. So let's look at another version or another prime example. So let's try number 11. So you do 11, pause this, and see if you can find a GCF of 8 and 15. Now, you probably got to a point where you figured out 8 and 15 don't have a common factor other than 1, but 1 doesn't really count. Because if we list these, we would have, let's see, 8 can divide by 1, it can divide by 2, it can divide by 4, and it can divide by 8. 15 could be 1, 3, 5, 15, but that's all we have. None of those are in common except the ones. That doesn't count, so this is prime. All right. So let's do this. You work some of these, and I'll give you the answers. So let's see. Number 4, actually, let's do that one real quick, and then I'll let you do the rest of these. If you want to pause and try to do 4 on your own, you can. The only thing different here is this R and this S is going to stay. If this R and S were the same letter, like if this was an S and this were, I don't know, the same thing as this, an R, then we could get into the factor out of variable game. But I don't think we'll see that in pre-algebra, but you will in probably algebra 1. So for now, though, you can just know R and S aren't the same, so those can't both factor out. They just have to stay put. So 6 and 48, we want to find the biggest common factor, which it would be 6. So we would divide both of these by 6. 6 goes on the outside, which means we're left with R minus, because that minus sign would just come down, or you can treat it like a negative 48. Either way, it works. 48 divided by 6 would be 8. So it would be a negative 8, so that's minus 8. And then we also have to add in our S, and that's our finished product. So if we distribute that back, watch what happens. We get 6R minus 48S, which is what we started with. So this is our answer. All right, so now you do a few of these. Try to do like, I don't know, try to do 7, 8, 9, 10, and let's see how you do. Then I'll write the answers. All right, so pause this, do those, and then let's see. So on number 7, hopefully you said the GCF would be 2. So that means we can divide each of these by 2, but nothing bigger. So 2 goes on the outside. Now 4 divided by 2 is 2, and then n comes down. So this would give us 2n minus, then we do 10 divided by 2, which is 5. Or you could treat this like negative 10 divided by 2 and say negative 5, which turns into minus 5. And that's our answer. All right. Yeah, that would be our answer. All right. I wrote it down wrong on my paper. I don't know why. All right. So then 10v plus 45. Once again, biggest common factor between 10 and 45. Let's see, this one would be 5, actually. You could divide both of these by 5, nothing bigger. So 5's on the outside. 5v, no, wait. 10 divided by 5. There we go. I got 2 ahead of myself. So 2v is what's left because we divide 10 by 5, and then we just bring down v. Then we have plus, which I have no clue how that came out that way. That should be 5. All right. So then we have plus 45 divided by 5, which is 9. So that's our answer. All right. So the next 6 and 21, let's see. The biggest factor would be 3. Yeah. So we could divide both of these by 3, which means 3 goes on the outside. 6 divided by 3 would be 2. So we're left with 2k. Plus 21 divided by 3 is 7. All right, then one more. 16a minus 12b. Once again, look at 16 and 12. Try to find the biggest number that divides both. That number would be 4. But the a and b have to stay because the a and b are different, so you can't factor them out. So 4 is on the outside. 16 divided by 4 is 4. A minus 12 divided by 4 is 3, and then we add our b, so we're finished. All right, so hopefully you did pretty well on those. Let's go to the back. And on the back, we've got, first of all, the word problem. Don't really worry about that. We'll dive into word problems later, but for now, skip that. This is the last part. So we want to simplify and then factor. So what we're going to do here is simplify the equation, which means combine like terms or maybe distribute. We're pretty much going to take what we've just done in the last 2 sections. We're going to combine those together again and then combine them all together with this. So what we're actually doing here is combining like terms. We're going to distribute and we're going to factor at the end. So this can be a little long, but let's just see if we can do it. So let's do an easy one first. So number 14, we have 4x minus 2 minus x plus 23. So there's nowhere to distribute, so we just have to combine like terms. So 4x and then negative 2 and 23. So that would give me 4x minus x, which is 3x. Negative 2 plus 23 would be plus 21. Now, I want to factor this because before, when we did 2.4, we were saying, okay, this is the answer. Now I'm finished. But now we're going to say, okay, this is not the answer. I want to factor it. So when I factor it, I can say, all right, 3 and 21 are my numbers. X would have to be here to factor it out. So just don't worry about X when it's only in one term. And then we look for a GCF. So 321 is my GCF, or tells me my GCF. My GCF would be 3. I can divide both of these by 3. 3 goes on the outside. I'm left with x plus 7. So I am finished. All right. Let's skip to a little bit of a harder one. Let's go to number 18. Yeah, let's go to 18. All right, so 18 now, if you look, simplifying means first we need to distribute, and hopefully this pops out in your head that I need to distribute that first. So 15a minus 10, because this is a negative, so when I do 5 times negative 2, it becomes negative, so I write that as minus 10. Then we can combine like terms after. So let's see, 15a, 13a, and then negative 10 and negative 2. All right, so 15a minus 13a is 2a. Negative 10 minus 2 stays negative, and then we add them, so it'd be negative 14. So 2a minus 14. Actually, I'm doing that wrong. It'd be 12. I'm crazy. All right, so 2a minus 12, not 14. And then we have what's left to be factored. Because remember, this says factor. All right. So if you look, hopefully it pops out in your head. 2 and 12, GCF is 2. The biggest we can multiply both of those by would be 2. All right. So then I bring 2 on the outside. Whatever's left over stays on the inside. So A stays on the inside, and then minus 12 divided by 2 is 6. So minus 6. And then I should be able to multiply back and get back to this. All right, so then let's do one more that's a bit difficult. Let's do number 20. Pause this, see if you can do 20, and then we'll do it together. So remember on this, you can't combine anything that has different variables. So when we look at 20, first we need to distribute. We need to distribute this first. But then when we combine like terms, just make sure you don't get the m's and the n's mixed up. So let's do this. Let's bring down everything that won't be distributed. Because when you do that, it makes it pretty obvious what's left, which is a negative 3. So we're going to distribute a negative 3 here, and the sign, if it's negative, we'll say minus. If the sign stays positive, we'll say plus. That way it's easy. All right, so negative 3 times n is negative 3m, so minus 3m. And then negative 3 times positive 6n would be minus, because the signs are different. So it would be negative, which is minus, and then 18n. Now, anything that has an m can combine. Anything that has an n can combine, but they can't combine with each other. All right. So now let's see. 9m minus 3m is 6m. Negative 6n minus 18n would stay negative, and it would be 24, I hope. Yeah, 24n. All right, now, finally, we have to factor this. So if we look at 6 and 24, both of these will divide by 6. So we can factor out 6, which means 6 goes on the outside. M minus 4n is left on the inside. Which I know some of those I'm doing fast, but I don't want to completely bore you to death with the videos. But that is that's it for 2.5. So remember, pay attention to your signs. When you get to this back portion, you're going to simplify, which means distribute, combine like terms, and then you're going to factor after that. All right. And then once again, factoring, kind of the reverse of distributing. We're basically going to look for a GCF, factor that out by dividing. It's going to go outside of a parentheses, kind of like this. And then whatever's left over after we divide stays on the inside of the parentheses.